Hey everyone, in this video I'll be showing how to take mouse and keyboard input using processing and Java. Before starting this video, you should already have processing installed and be familiar with how to draw shapes and colors with processing, as well as how to use variables and conditional statements. If you need a refresher on those, you can go through the previous 3 videos in this series, which are linked in the comments. Let's go ahead and get started. What I have here in processing is a setup function which sets the size and background of my window, and a draw function which draws a circle in the top left corner of the screen. And if we run this, we can see that our circle is being drawn right here. And so the first thing I want to do is show you how you can use the X and Y position of the mouse. So we're just going to go ahead and actually set the X and Y position of this circle based on the X and Y position of the mouse. And we can do that using mouse X and mouse Y. And now if we run this, instead of drawing in the top left corner of the screen, we can move the mouse around and we can see that it is drawing the circle wherever we move our mouse. Now remember that draw runs continuously. It runs about 60 times per second, and so it is always just drawing on top of whatever was there before. And when in the previous video, when we did animation, we looked at how we can add a call to background on every draw frame. That way we're clearing what's already on the screen. So I'll go ahead and add background 200. And now the mouse is controlling the circle, but it is clearing on each frame, and so we only have the single circle. Now if we wanted to get whether or not the mouse is being pressed down, we can add a conditional statement. I'm going to add it above where the circle is being drawn, so we're going to add an if conditional statement here. We're going to check if mouse pressed. So this will be true when the mouse is being pressed down, and it will be false when the mouse is not being pressed down. So I'm going to add these curly brackets here, and then in between the curly brackets I will change the fill color to 0. Now let's go ahead and test this. And so now once I click the mouse, now the circle turns black, but I've released the mouse now and it did not turn back to white. If I hit stop and run again, now it's back to white, but as soon as I click, it is black and it stays black. So we can switch it back with an else, and in between these curly brackets, we can set our fill to 255, which is white. And now while I am pressing down, it is black, and when I release my mouse button, it turns back to white. So this shows you how you can use the mouse X and mouse Y to position something, and you can also use the mouse pressed to determine whether or not the mouse button is being pressed down. A couple of other useful ways to collect the mouse input is with a couple of specific functions. Similar to how we have the draw function and the setup function, there are some specific input functions. There's one called mouse clicked. And this happens when the mouse is clicked, which is different from the mouse being pressed, which is true for as long as the mouse button is being pressed. The clicked is the full press down and release cycle. So let's go ahead and add a print statement here, and we'll just print the word clicked so we can see how this works. And now when we run this, when I press it, I'm still getting my circle turning black. If I release, it does not actually print anything yet, but if I click and release, now I get the clicked print line. And the reason it doesn't happen when I am moving it around and then releasing is because that's actually considered dragging, not clicking. So the clicked only happens with a press and release when the mouse is stationary. As soon as the mouse moves, it's no longer considered a click. We can add the check for dragging. So let's go ahead and add the mouse dragged function. And here we can add a print statement for drag. And run this. And now when I press and drag the mouse around, I can see it is printing drag. It's actually printing it a bunch of times. It is printing continuously while it is being dragged. And then if I just single click, I can see a click has appeared there. And then if I drag again, I can see a bunch more drags have happened. So Drag is being called continuously while the mouse is being dragged, and click is a single thing that happens when the mouse is pressed and released in the same place. And then alternatively, you can determine on any frame, is the mouse being pressed down during that frame using this mouse pressed variable. So the last thing with the mouse input is you can also check how close the mouse cursor is to something. For example, if you wanted to have a button or something on the screen that you could hover over or click on, and you want to know how close the mouse cursor is to that. So I'm going to go ahead and get rid of these two extra functions, and I'm actually going to set this draw function back to just the single circle. I'm going to put this in the center of the screen. We'll do width over 2 and height over 2. And just make sure that's working. All right, so I have a circle in the center of my screen. So now what I want to do is I want to check where the mouse cursor is relative to the circle and see if the mouse cursor is over the circle or not. So now we're going to use a math function called dist, D-I-S-T, for distance to check the distance between two things. I'm going to put this in an if statement. So this is going to, inside of our parentheses here, we're going to have a condition, and the condition that we want to check is the distance between the mouse and the circle. So I'm going to use this dist, and what this math function is looking for is 4 values, an x and y value for the first point and an x and y value for the second point. So I'm going to use mouse x and mouse y for the first coordinates, and for the second coordinates I'm going to use the center of the circle, which is width over 2 and height over 2, since I placed the circle in the center of the screen, so I'm just going to use those same values. Now, it might be a good idea for me to actually have a variable where I'm storing the position of the circle. That way, if I ever wanted to move the circle, I wouldn't have to change the value in both places. I am actually going to go ahead and do that now just to show how useful it is to store variables for things. So I'm going to create 2 new variables up here at the top. I'm going to make an int x. And I'm actually not going to set it equal to anything yet, because before setup runs, we can't access the width and height of the screen. And then I'll make a second int called y, and then inside of my setup, I can set x equal to width over 2. So this will be the center of the screen, and y equals height over 2. And now I can actually use those x and y values for my circle position and also for my distance calculation. So this dist, and then open parentheses, mouse x, mouse y, x, y, close parentheses, and this is going to return the distance between these two points on the screen. And so it's going to be a positive number. It's going to calculate the distance between them, and it is going to, we are going to check if the distance is less than, and the value we're going to check it against is, we actually want to figure out, so this is the size of the circle, this is actually the diameter. So we want to take half of this value. So the radius of the circle is actually what we want to compare to. So I could just put 25 in here, but just like I did with setting the x and y values, instead of having a value that I'm setting in 2 different places, it is better to make that a variable. So I am going to say int r, so this will be my radius, and I'll go ahead and specify that in my setup function. So we'll do r equals 25, and now I can use r in my distance calculation. And here, since this is supposed to be the diameter, here I would use r times 2. And so now I have extracted all of my numbers out into variables so that I could easily change these values just once, and I wouldn't have to worry about redoing things. Now I need to specify what to do in the case where this is true. So when the distance is less than the radius, so that means the mouse is actually over the circle. So what I want to do here is I want to change the fill color. I'm going to change the fill color to 0. And now let's go ahead and run this and just see what happens first. So here's my circle, and when my mouse cursor enters the circle, it turns black. You'll notice when I move my cursor away, it does not go back to white. So we want to specify what the color is before change. So I'm going to add that up here before the if statement. I will set the default value to 255. And then if the mouse cursor is over, then I update the value of the fill to 0. So let's try that again. All right, so now when my mouse cursor enters the circle, it turns black. And if I move back out, it goes back to white. So now I am accurately detecting when the mouse cursor enters and leaves the circle. Now, what if instead of a circle, I have a rectangle? So I'm going to change this to rect, and I, instead of using radius, I'm going to make a width and a height. And instead of making a whole bunch of variables like this, you can actually combine lines together like this. So you can make more than one if they're all going to be the same type. So I could move my X and Y to the same line. If you're not specifying what they are equal to, you can just add multiple variables separated by a comma. I could even put all of them on the same line, but I'm just going to keep them grouped in a sort of meaningful way. Okay, so in my setup function, let's say our width is 80, and I'll just make it 40 for the height. So we have a width of 80 and a height of 40. Maybe this is going to be a button, so it's wider than it is tall. And now let me get rid of my radius, and instead I will use width and height. And first of all, the main issue here is it's not actually centered on the screen because X and Y is the start of the corner. So in a previous video, we looked at how to position something so it's actually centered. So to do that, we would subtract width over 2, or W over 2 rather, and from the Y, we would subtract H over 2. So now the rectangle is actually centered in the screen, and I can see that it does turn black when I hover over it, but you'll notice it's not consistent with the edges of the rectangle. So all of this space in here is part of the rectangle, but it's not turning black. And it does turn right when I enter the bottom right here in the top, but there's a great amount of space on the edges that is not detecting it. And that's because it's actually still detecting a circle when we use the distance, because it is calculating the distance to the center of the rectangle. So it is making a circle around the edges. So rather than using distance, we can change the way that we are detecting if the mouse is within the rectangle, and we can instead try using the edges of the rectangle for our bounding values for X and Y. Before we switch to calculating based on the edges of the rectangle, I do just want to show what happens if we increase the distance that we are checking for. So our largest variable here is W, and so if I checked, I would actually want to do W over 2, so that it is checking half the width of the rectangle. And so we could increase the distance we are checking by, and now it accurately detects the edges out here. However, it now also detects a distance outside of the rectangle at the top and bottom. And if we had, even if we had a perfect square, there would still be parts of the corner that were not accurately being detected, or we would have extra space around the edges. So when you're dealing with a square or rectangle shape, we want to be accurate with the hover over, and so we want to use the edges to make that calculation. So instead of this distance calculation, I'm going to get rid of this. And inside of our if condition, this is where we're going to try to figure out whether or not the mouse is to the right of the farthest left edge of the rectangle and to the left of the farthest right edge. So let's check with our mouse X, and we first want to see if it's greater than the farthest left edge. And so the farthest left edge is going to be this X minus W over 2. This is the starting corner. So X minus W over 2. And then we also want to check, and we can check more than one thing at once using the double ampersand, which is and. So we'll check this condition and another condition, and it will only be true if both conditions are true. So we can also check if mouse X is less than, and here we want to do X plus W over 2. So now we can run this and test it. And so now we can see it is accurately detecting the left and right edges. I'm not doing anything with the top and bottom though. So it is actually detecting anywhere on the screen where the X values of the mouse are correct. And it is not doing any calculation on the Y values of the mouse. So that's the next thing that we want to add. We can actually still add it in this same if check. So we can add another ampersands and do mouse Y greater than, and what is our Y values? So we have our top of our rectangle at Y minus H over 2. And then we also want to check if our mouse Y is less than Y plus H over 2. Now we can run this and test. And now I can see my Y values are working correctly and my X values are working correctly. So now what we have is an accurate detection of whether or not the mouse cursor is inside of this rectangle or outside. And so with that, you now know how to use the mouse X and mouse Y values both for positioning things on the screen as well as for determining how close the mouse is to something. And the last thing we might want to do is to be able to check if the mouse is being clicked or pressed while it is inside of something. So if this is a button, I want to not only be able to tell when the cursor is inside, but I want to be able to also tell if the mouse is being pressed. And those are two different states. With a button, you would have a hover state and a press down state. So I'm going to add a little bit more to this. And first, let's just take a look if we added a second if condition down here. If we used mouse pressed before. So if mouse pressed, and let's add a different fill color here. Let's do 0 to 55, 0, so it'll turn green. And now if we run this, the hover over is still working correctly. And if I click on it and release, while inside of it, it turns green. But the one issue is now if I click somewhere else on the screen, it is still turning the button green. And I only want to turn the button green if I click on the button. So what I can do is I can make a nested if statement. I can move this if condition, if mouse pressed, inside of my other if statement. Let me just fix a little bit of my indentation so it's a little easier to read. So this is a nested if statement. So first we check this if condition. We want to know first, is the mouse over the rectangle? If so, we change the color of the rectangle. Then we check again while inside of here. So that means this was already determined to be true. We are already hovering over the rectangle. And now we check if mouse pressed. So this is only going to happen if we are inside of the rectangle and the mouse is being pressed down. So now if I click anywhere out here, nothing happens. If I hover over and then click, now it turns green. So this is kind of an expected behavior of a button. So you would hover over and change color and then click and change color one more time. And it unhovers when the cursor moves outside of it. That is all of the things probably that you'll need to know about mouse input for now. So let's move on ahead to keyboard input. So I'm going to be making a new sketch for this, and so it's important to save your work from time to time, and you probably want to do save as, so you can name your file something meaningful rather than a sketch and then a number. So I could call this mouse input practice and save that. And now I can create a new sketch. And so now we can begin working with keyboard input. So I'm going to start with the same setup that I had before, just setting the size to 400 by 500 and setting the background color to 200. And I have brought in my empty draw function. Now before I set anything up in the draw function, I want to show one more new function that we're going to use for the key pressed. So this one is called key pressed. And this is called whenever a key is pressed on the keyboard. And so if we want to just check for any key, we can just add a print line statement here. And I'm just going to print out any key. So I'm not checking anything that is particularly happening inside this, but this is being called every time a key on the keyboard is pressed. And so if I run this, here's my empty sketch, and if I press a key on the keyboard, I can see any key is appearing down here, and I'm pressing different keys, so I'm getting this no matter which key I press, and we can see it is continuing to happen. So now I want to check for some specific keys. Let's say I want to check if the key pressed. We get this special variable called key, and I can compare this with the double equal sign to whatever I want to check for. And so let's say I want to check for the space bar. If you use the single quotes, that is a character as opposed to a string. So we have a single character for a space. So I've just typed space in between there. And so now this key pressed is going to check if the key that was pressed was the space bar. So I can add a print line here to say space bar. And now if I run this, and if I press other keys, nothing happens. I'm not getting any print out when I am pressing other keys, but when I press the space bar, now it is printing out space bar each time I hit the space bar. Now if we want to check for something like the arrow keys, we're actually going to use something called a key code. And so instead of checking a specific value of the key, I'm going to check if the key is a coded key, and if the specific key code is up. And notice I'm not using quotes on any of these. I'm using all capital letters, which is a shortened version of a Java constant, which we can use. So the up is represents the up arrow on the keyboard. So I want to change what is being printed out so that this makes sense. So I'm going to change this to say up arrow. And now when I test it, now when I'm pressing other keys, nothing is happening. But if I press the arrow keys and I press the up arrow key, it will print out up arrow down here. If I press the other arrow keys, nothing happens. Let's go ahead and make this a little more interesting by adding a rectangle that we can move around with the arrow keys. So I'm going to make a int y at the top, which I will set to, let's just set to 200 for now. And then in my draw function, I'm going to make sure to draw the background so that we clear whatever was already drawn. And then I'm going to draw a rectangle, and I'll set it at x equals 100. I'll use y for the y value, and we'll just do 80 by 80 for our width and height. And now inside of my key pressed in my if statement, instead of printing out up arrow, when the up arrow is pressed, I'm going to change the y value. Remember, higher up on the screen is actually lower y values, so I'm going to subtract. I'll do minus equals 5. So we'll subtract 5 from y each time the up arrow is pressed. And when I run this, now I can see when I press the up arrow, it is moving the rectangle up on the screen. And if I hold the up arrow, it moves the rectangle up continuously, although it's not very smooth. We'll fix that in a second. But first I want to add the other arrow keys. So I'm just going to take my current if statement. I'm going to go ahead and copy and paste this 4 times because I have 4 arrow keys. So I'm going to also check down. And for down, I will change y to plus equals 5. And now I also need a value for x, so I can use my left and right arrow keys. I'll go ahead and add left and right here, and now I'll add a variable up at the top. X equals 100, and I'll change my rect to be use x for that first variable. And now down here in my left arrow key, I want to say x minus equals 5, and for my right arrow key, I want to say x plus equals 5. So now with the up arrow, I will subtract from the y value. With the down arrow, I will add to the y value, which will move it down the screen. With the left arrow key, I will subtract from x, which means I'm moving it to the left. And with the right arrow, I will move it to the right by adding to x. And so now when we run this, we can see that the rectangle moves the direction I am pressing on the arrow keys. Now, again, it's not very smooth, and so we are going to fix this, but we can see that it is accurately capturing the different arrow keys and applying that to the rectangle. Okay, so to smooth this out, what I'm going to do is I'm going to add a couple of extra variables at the top, and these are going to be to determine the change in x and the change in y. It's kind of a convention to use dx and dy for delta x and delta y, or change in x and change in y. So we'll do dx equals 0 and dy equals 0. So by default, the change is 0. And then I'm also going to add a speed. And I'm going to go ahead and set that equal to 4. Now, what I want to do in my draw function is, before I draw the rectangle, I want to update x and y based on the expected change in x and y. So I'm going to do x plus equals dx and y plus equals dy. So whatever I am specifying for the change in x and the change in y, I will update those before I draw my rectangle. Now, to set the dx and dy, I'm going to do that in key pressed, and then I'm also going to add a key released. So while the keys are being pressed, I am using a certain change in x and y, and then when the keys are released, then I will reset change in x and change in y to 0. So I'm actually going to go ahead and, before I copy and paste this, let's put in, let's change our up arrow behavior to say dy is going to be negative speed when I'm pressing the up arrow, so the speed is going to be going upward. And then for the down arrow, I will set the dy, or change in y, to equal positive speed. And then for my left and right, for left, we'll do negative speed for x, and for the right arrow key, we'll do positive speed. Now I am going to copy and paste this. Oops, let me get the whole thing. So this is for when the key is pressed, and we want to do something very similar when the key is released. So I'm copying and pasting this so I don't have to retype all of this. So when the key is released, I'm still checking first if the key is coded and then what the key code is. And I want to reset each of these to 0 when that key is released. So this will actually allow us to have multiple keys pressed down at the same time, and it will update the change in x and change in y based on which keys are being held down. So I'm just going to reset all of these to 0. And let's test it out. And make sure you do click on the window before you try pressing the arrow keys. It actually doesn't accept the arrow keys when you have a different window selected. Okay, so now it is actually moving pretty smoothly. And it allows me to press multiple keys at once, which is great. The one last thing I might want to add to this is, you can see I can actually go off of the edge of the screen. I might want to bind this to the edges so that I can't go outside the edges of the screen. So to prevent it from moving off of the screen, I want to add a check before I update the x and y values. So what I want to do is, I don't want to update x and y if their new value would be outside the boundaries of the screen. So I'm going to add an if condition above each of these to check if it will still be within the screen before I update it. But to simplify this, I also want to be using I want to be able to determine things based on the center of the rectangle. And as we know, in order to do that, we want to subtract half of the width from our x value and half of the height from our y value. So instead of, I'm not going to go to the hassle of making variables this time, although that is what is best to do here, but I am just going to subtract 40 from each of these. So now my x and y values actually represents the middle of the rectangle, which will just make it a little bit easier to do my calculations. So up here I'm going to add if x plus dx is less than, so this will be the new value. This is once I update the value, will it still be within my width? And here I want to subtract half of my my width of the rectangle, so I'll subtract 40 here. And I also want to check if x plus dx, so again this is the new value, if this is greater than, and so the other side of the screen would be 0, the left hand side of the screen, and so I just want to add 40, which is again half of the width of the rectangle. And I'll add a close curly bracket after this, fix the indentation. So now it should not update the x value if the new value would be outside of the screen, and we just want to do the same thing with y. If y plus dy is less than height minus 40 and y plus dy is greater than 40. And we'll add an indentation here, and let's test this out. And now my rectangle stops when I reach the edge of the screen. So now I can move my rectangle around using the arrow keys, and it will not leave the screen. So that gives us some basic keyboard input using the arrow keys. So with this video, you have learned how to accept mouse input, including both whether the mouse is pressed or not, and the X and Y positions of the mouse. And then we have also learned how to accept input from the keyboard and to use the arrow keys to move something around. So I hope you have found this helpful for adding input using mouse and keyboard with Java and processing.